So our first panel for the afternoon is on smart energy, air management and water, and how that kind of contributes to the bottom line. If you'll give me 1 second to get myself squared away. So what I'd like to do here is this. Basically I'd like to go from right to left and start down here with Chris. And what I'd like you to do is quickly introduce yourself. And quickly means quickly.
Thanks, Mike.
Okay, quickly introduce yourself. Tell us what company you work for, what you do, and what your role is in the IoT, in the IoT infrastructure, what it means to you.
Excellent. So I'm Chris Garyet. I'm with Sigfox. We are a network provider, an internet service provider for IoT devices, and that means that we are the connectivity piece between the edge, the device at the edge, and the cloud. So that's where Sigfox plays. We invented our standard, which is the Sigfox standard, and we maintain the network around that standard and bring ecosystems of people together to solve the IoT problem.
My name is Peter Lake. I'm a board member at the Texas Water Development Board, which is the state of Texas water infrastructure bank. So we spend a lot of time financing a variety of water projects across the state, as well as managing flood challenges. So we see a lot of advanced metering infrastructure, things like that, and also deal with a lot of IoT in the flood space. And of course, ag is always big in Texas.
So my name's John Miri. I'm Chief Administrative Officer at the Lower Colorado River Authority, which is based here in Austin, where we do three things: water, power, and community services. So first off, thanks to Peter, who are our bankers and are financing our $250 million reservoir construction and the first new water supply project in Texas in, I think, 4 or 5 decades. So really appreciate their support on that. So my interest in IoT is that I kind of come from the technology space. I'm actually at my core an internet startup guy who sort of got lost or found his way somehow into being the leader of technology and cybersecurity and shared services for a water and energy company. And so the internet is kind of how I sort of view the world, and I think it's the way we look at it to in the LCRA context is that I think the internet is becoming kind of the platform of the architecture for all infrastructure, and in many ways can help reshape our physical infrastructure so we can get a lot more out of it and have it perform better while building hopefully less of it. So that's why I'm glad to be here.
Great, thanks very much. I appreciate it to all of you. So let's start this out, and by the way, I will leave some time at the end for questions, so please, and we hope that you have questions out there, so hold those for a little while, and we'll get to those before we get to the end. So Peter, I'm going to kind of start with you and ask you to, when you think about smart technologies, when you think about IoT, when did you start and what areas did you start looking at first?
Well, first and foremost, at the Water Development Board, we are primarily a bank, so we get to see, I guess for lack of a better term, a lot of deal flow in municipalities and river authorities coming in. So we see a wide range of applications, everything from advanced metering infrastructure to pipeline, like smart pipeline sensing technology. And as the banker, we very much look at it as an ROI point of view and getting the most mileage out of our dollar. But also as a state agency, we look at it very much as the highest and best benefit for the citizens of Texas.
Okay. So what exactly? I mean, what comes to mind when you think about the technology portion of it? I mean, is smart metering really the primary thing that you look at, or is what from that perspective, what do you see in front of you?
So in smart metering, that's a big water conservation, cost saving, and there's of course a big back end data aggregation element that helps us manage and municipalities manage their water use, their customers' water use, and the overall efficiency of the system. We see most entities, depending on where you're in the country, have 20 to 30% of water loss just through pipelines. So it's not real cutting edge, and it's not something at a retail kind of customer facing. But anything we can do to eliminate that loss in the ground, whether it's pigs going through the pipes to identify seismically real time the efficiency of the pipes to the meter at the tail end, anything like that is helping us solve the biggest problems first. In the flood world, our agency is responsible for helping manage flood disasters across the state. There we've got, we're starting to utilize smart stream gauges, and we're linking those up with soil moisture probes to see what kind of absorption rate the area can handle up and down river basins. LCRA has an outstanding system as well that we're integrated with.
So can you just quickly clarify what a smart stream gauge
So
is?
just measuring,
Just so everybody knows exactly what.
sorry,
Okay.
measuring stream levels up and down a river basin, in addition to weather conditions, so rainfall, wind, and then also soil moisture. So of course, the drier the soil, the more water it can absorb. If you have real wet soil, your rainfall is going to go in your river and raise that level a lot faster. And we're integrated that with LiDAR data, which is measuring topography at a very precise level from aircraft or drones. And we can roll all of that in together into essentially a flood predictor tool that we coordinate with the Army Corps of Engineers. So we know we can get, hopefully in real time, how much water is being dumped in a river basin, the topography of that river basin, and we can model that out to see how high the water is going to go, when it's going to get there, and how far into a community it's going to go. And we have a public-facing app, that texasflood.org, that you can get on your phone, that you can see your stream gauge, you can subscribe to the gauges in your area, you can get alerts when the stream gauge up from your house hits a certain point, and you know that's get out of town.
Yeah, got it.
And we can also tell the state emergency responders, you know, you need to go to this block. This block's going to be fine. The water's going to go 3 blocks deep here, but don't worry about here. So we get a lot more utility out of our first responders, and are hopefully doing a good job saving lives and protecting property. So that's been something that's really compelling for us to put all together.
Got it. So John, can you piggyback on top of that as kind of the guy downstream from Peter in a lot of senses as to what you're seeing and on top of this, what you're doing?
Sure. So, so we're involved in a lot of the same types of issues, and I think part of that comes from the fact that, you know, moving on good days, a big part of our mission is moving molecules of water to get to municipal water systems and agricultural customers downstream. On the bad days, our job is to keep floods and too many of those molecules ending up in the wrong places. And you know, the nice thing about technology and information is that the data that moves through those systems moves a lot faster than the water does. And so what we're finding is, just like you're seeing this kind of movement of smart and everything, from smart bombs to smart roads to smart transmission lines and so on, that if we can make those systems that either are intended to distribute water or intended to keep people from being harmed, you know, from the excess distribution of water, the smarter we make those systems, the more efficiently they run, the better they achieve their purpose. And so, you know, we actually got, so what's funny is one of the first projects that our folks started doing that was IoT based, they didn't even realize that's what they were doing. They wanted to add some control systems to our agricultural water distribution system. It's very low, you know, that's a economically challenged area. There's not a lot of money to go run that system. And so they said, well, we need control systems, and we need remote connections, and we need to open and close things, and we have to operate, we have to pull data out of this system, and we have to send instructions to control systems, and we need a cheap and easy way to go do this, and we can't pay for some proprietary thing. How could we do this? And a couple of smart engineers were like, well, TCP/IP is kind of a data transport protocol. Maybe we should just use that, and I can find programmers who know how to go do it, and they go do it. And so they said, well, look, here, we kind of MacGyvered this agricultural control system. What do you think? And I was like, you know, this is IoT. And they're like, wow, we should talk at conferences. And
The,
you know,
the magic
really,
of IoT,
like,
it just shows up.
it just showed up. And so, you know, I think it shows that there's a business case and there's cost savings, I think, that can come out of that, because it really, at least in our case, that was what kind of sparked them to think about it. Was they were like, well, I didn't even know, I just knew this technology could help me solve a problem. So
That's very cool. Chris, I want to kind of move over to you, because you're one of the guys who provides the infrastructure that allows them to do this and connect all this stuff together. And you also have a worldwide perspective to some extent that I like to ask, because Sigfox, you know, is all over the world. So can you tell us a little bit about your thoughts on and what you're seeing in terms of connectivity for, you know, basically the water, air, and that kind of energy management space?
Absolutely. So Sigfox itself is a standard built around low power and low cost connectivity. So specifically devices that are battery-operated devices that need to last in the field without user operation or without user, changing a battery, coming down on there, without user provisioning. You really just want to turn it on and have it go. And so those devices typically last anywhere from 5 to 10 years, and we've invented a protocol that basically makes that a reality from a connectivity standpoint. So deploying those devices all over water infrastructure to create the monitoring for the sensor type applications that allow you guys to collect the data to tell people to get the heck out of town. We've been involved in those with municipalities all over the world, specifically some in Texas, specifically out in France, where we're headquartered from an international standpoint. And the reason why we can do that is because we maintain the network and provide those levels of connectivity for these devices that have previously been unconnectable devices, or that you've previously had to run out power lines for, or only put in strategic locations. So you can move from monitoring your river and doing a topology map once a year to figure out the basin, and you can move from just monitoring those specific stations on there to actually monitoring individual like intersections in cities, so that you say, not only is it a predictive thing, but you can actually measure now at the intersection level where the water level is quite high. And so you can then use Google Maps to reroute people around when they're doing travel. You can make sure that the first responders have an idea of where they are. And we can see that progress because the network is prolific, and then also because the cost point is so low for the integrators and the people that are very concerned about the ROI calculations.
So we're connecting all this stuff up, and I'm going to go there right away because I might as well.
Sure.
Security. And let's talk about security. And I'd like to start actually from your two gentlemen's perspective first, which is, how much do you think about it? I mean, are you as anally thinking about it as I am on a regular basis? And is it at the top of the list, the middle of the list, the bottom of the list? Where does it appear on your list? And how do you deal with this whole security issue?
So I'll jump on that grenade first, and that's part of our service. Find our reservoir, and I'll jump on the grenade. Go ahead, John.
That's a great deal, by the way, if you can get it.
I think I still owe him, but it'll help. So for security, obviously, so security is a huge deal for us. I mean, from the water side, but from the energy side as well. So LCRA is the second largest power transmission company in Texas. We do a lot of power generation. A lot of the folks in Central Texas rely on us to have this basic infrastructure. When I was first coming to LCRA, I thought, well, I won't have to worry about security all that much because we're wholesale. We don't have a lot of personally identifiable information for citizens. So, like a security breach is not, what's the end of the world? We lose our employees' information, that's terrible, but it's not like healthcare or something like that, where you have a lot of that personally identifiable information and you have to send out those terrible letters that say, we lost your stuff. I was like, we have critical infrastructure.
Yes.
And so, it's a big deal for us. We have I sat next to, so I report to Phil Wilson, who's our general manager, the head of our agency. I sat next to him at our board meeting, and he said, when I started at this place, getting commodity risk management in place to handle variations in the energy markets was my top priority, and now cybersecurity is my top priority. So the first year I was there, we doubled our spending on it. We've added another $3 million this year. We've increased the size of the team quite a bit. It's a big area of investment for us because there is nothing that will take away or erode the economic and the functional benefits that we want from these new technologies, like people losing trust in the security of those systems. So we can't let that happen, and we will lose all those business benefits. We'll lose the reputation of our organization if we don't work really hard on that. So staying ahead of that is a really big deal. Our chief information security officer reports into me, and we actually also elevated that so that previously a lot of those functions were within IT. So now it's a standalone group equal to the CIO, who also reports to me, and on an equal footing, and very much at the seat of the table. And I'll tell you, I was impressed. Our internal customers, our water customers, and I call them the other groups within LCRA, my customers, the folks running our water business, our power businesses, and so on. They're in it too. They've prioritized their cybersecurity projects over some of their own operational infrastructure projects, and said, I'd rather actually wait on fixing this thing or wait on doing this thing because I can't I've got to be sensible on security. That being said, you have to make risk-based smart decisions, and you can't secure everything. And with IoT especially, you're in a little bit of a frontier. And so we're not going to wait until everything's completely foolproof, but we want to make sure that we're really, my goal is to kind of be, never going to be perfect, but be in that really, really high, high kind of couple percentage points of our benchmarking organizations.
Yeah, again, it's top of mind for everybody in this particular specific list. So, Chris, I'm going to jump over to you because
Sure.
it's got to be something that you're.
Absolutely.
That's got to be actually probably the #1 question when you come to dealing with a wireless network.
So actually, it sometimes is, but it sometimes isn't the #1 question, and it's
Should
because
it be, by the way?
Possibly it should be. It's certainly on the, and from your perspective, it should be. Obviously, the type of data that you're securing. So let me explain a little bit about the Sigfox network. So specifically, we're transmitting 12 bytes of data that go up from sensors, and we're doing it once every 10 minutes or so. It's a bidirectional algorithm, but at the most, what you're doing is doing 140 messages up per day and 4 messages down per day. So in that 12-byte message payload, if we're talking from edge to base station, and this is one hop, by the way, from device on the edge through base station to cloud, edge to base station, you can compromise one device, and we have encryption around that. But I mean, theoretically, somebody could compromise one device, but it doesn't give you any sort of substantial data because typically people are broadcasting like literally ones and zeros, in the same way that you do with kind of traditional manufacturing standard, like wireless or wired standards. So typically when you get one device, it doesn't do you any good. The real security concern is in that backhaul from base station to cloud. And that's the part that certainly Sigfox is focused on. But it's not just us alone. As you mentioned earlier, there's a lot of partnerships that go into that. So working with people like F5 Networks to prevent, like understand the data on the front end after it leaves the base station to make sure that it's authenticated from base station to cloud. Working with VPN tunnels to make sure that that network is authenticated no matter what the backhaul is from base station to cloud, and then having strict cloud blockchain capabilities to be able to make sure that the data is encrypted in the cloud and distributed enough in the cloud where if there was somebody to get into it, then they wouldn't be able to take down the whole system. That's where we're really focused on from a security standpoint. So,
yeah, and I think from my my earlier comments as well, my issue and I think people's issue in general, data is one thing. Right? I mean, it's the actuation on the other side that I really worry about more. So it's the guy getting a hold of a valve in in a gas plant, okay, that goes in like target through the HVAC system, or like the other breach that we saw, a drone flies overhead and injects a malicious virus into a wireless valve, opens a gas valve, and that's the last we hear of that. So those are more the concerns,
Sure.
obviously, rather than just data transmission issues. And look, we've all lost our. Anybody here not lost their credit card number at least once and hasn't been monitored for at least a year? Because I'm on like my 5th. I think between Home Depot and whatever, I think I'm on my 5th year of free monitoring. So that's the ones I really get more concerned with than just the data monitoring.
That's a very good point. And I'll add something to that to say that you mentioned earlier about where data is stored and how that's a very specific concern. And Sigfox, as an international company, deals with countries that are very, very concerned about data leaving the country. So our servers are in France. However, some of our new contracts, as we're opening up new territories and new countries, require that those servers be inside of the country that we're in. And so having that capability to distribute and help, basically localize the data is something that Sigfox has solved as a problem so that we can operate in these countries that are requiring people to keep the data inside the country. So that's certainly a security piece.
Yeah, that makes certain logical sense.
Yeah.
So I want to branch off this for a second. And what I want to do is I kind of, Peter, want to ask you about ROI as a banker.
Sure.
And as his banker specifically. Because buried in the scenarios that we're talking about is both a hard ROI and a soft ROI. And I'm curious, actually from both of your perspectives, as to, are you seeing the hard ROI first, or are you seeing the soft ROI first and hoping that we're going to get a hard ROI in the long haul? You kind of understand where I'm going with this question?
Absolutely.
Tell us about that a bit.
So we're kind of in a unique position as a state agency as well as a bank. So like for the flood applications and that kind of integrated network that we've built, that's purely a customer service oriented, start at the top. We're solving an acute problem of people dying from floods, stop that happening. You'd move down to minimize damage and so on and so forth. So that's what we're solving for first and foremost. But as I guess a secondary element of that, you get a lot higher ROI on your first responders, your emergency services.
Okay.
You need fewer DPS troopers, you need fewer ambulances, and you can preemptively build, put up sandbags and things like that around things.
Okay.
And we've had some great scenarios, like in the Sabine River last year. Our folks said, guys, this is where the water's coming to. It was going up to a pump station that was drawing water out of the Sabine River. Built a sandbag wall around it. The water and then we had an after picture where the water was right around that sandbag wall with the pump station high and dry right there in the middle. So that's one version of that. On the more direct kind of municipalities putting in AMI, the hard ROI is the first one we see.
Right.
And that's cost reduction in the amount of labor you need going around town checking water meters at the most basic level. You get higher revenue because you can bill for the water that you're actually delivering.
Right.
You, from a kind of a water management perspective, your customers, and this is the kind of the soft ROI, is your customers are much more aware of what they're using when they're using it. So they're hopefully a little more involved in water conservation. But you also have much more precise and immediate leak detection. So if you're on vacation for a week and you're looking at your daily water use, you can see a problem a lot sooner than you would have, even if it gets lost in your normal activity.
Okay.
And of course, then there's finally the customer service element of that. When you have users that have a much better understanding, your customers have a better understanding of what they're getting, what they're paying for, and why all that works.
Got it.
So kind of a hybrid version.
Okay. John, thoughts?
Sure. So I think in general what we're seeing is more, I mean, for me, I think my view of the world is there certainly are some soft ROI projects that you need to do, and usually I do those because someone else makes me do them.
It's not measurable, and it's not in your nature, is it?
Right. I mean, I was a physics major. I'm very black and white back in the day. So I really think soft ROI is for slackers. I'm just kidding. No, it's not. I'm joking. There's lots of
We
great
have
soft
serious
ROI
problems
projects.
now.
I'm just trying to make your panel interesting.
Oh, there we go.
There's a lot of great, I mean, there are a lot of great benefits that you can't directly measure, but I think where we're really looking is for things that do have an impact on either a direct cost of ours or a direct cost of our customers, to say, well, if we do this, that cost will be lower, or to Peter's point, the types of things where there's in the public safety type realm, that there is a direct benefit to lower loss or lower loss of life or something like that, lower property damage. Those things are things you can quantify as well. The system I was telling you about that's part of moving water to the irrigation systems, we were going through the cost of different portions of it, and I thought this will be interesting. And some of the business people were saying, well, this doesn't seem fair. How come these people have to pay this price and these people have to pay that price? And I was like, I want to see what the answer to this is. I said, well, we've upgraded the systems over here. It just costs less. We charge people what it costs to move the water, and it just costs less to move water to them. It's like, well, that's good. I want to hear more of that. And I think we really want to, there's a lot of great things out there that are fun and interesting, and they're innovative and they move the ball forward. But if it doesn't really have some measurable benefit, either on a dollar side or on some tangible metric, like, people are safer, or, you have a faster response time, then you're really kind of might be just doing it for fun. So.
Got it. Okay. So we've only got a few minutes left, so I do want to ask if anybody out there, any specific questions out in the audience that would like to get asked. Otherwise, I'll continue on, but I want to make sure everybody out there, any questions? Go.
What type of energy harvesting strategy do you have for your systems? How do you do the energy harvesting?
Sorry.
How do you do the energy harvesting?
Our energy harvesting systems is the question. Are you talking about like an ocean?
No, more than that is that, for instance, you deploy these devices along the river, right, for the water sources. How do you harvest the energy from those devices?
Oh, he's talking about actual energy, such as small devices other than a big dam.
Yes, sir.
Got it, is what he's actually talking about. Are you using any of those or looking at any of those kinds of systems?
So do you mean how do we power our sensors and our gauges? Yeah. So all of our gauges are solar panels now, and unfortunately they're not as we would hope maybe some point. They're not low power. low-cost devices.
There
Well, we can help.
are glass roof panels will be out any day now from Mr.
We have almost as many telecom towers as DPS. So there's a future in
we could
low-cost,
definitely help.
low-power networks.
There's a guy with a card at the end of the table who's all over this one.
We'd be interested in learning more about that.
Sure.
So, other questions? Any other questions from the outside here?
I have one, but it was just a general question in the context of Texas. We see sudden levels in terms of floods, and then suddenly the next thing that we see is the drought. So is that something on your plan in terms of managing that aspect in the context that you've spoken, in order to address it in a much more better way, and also in terms of conservation of water, that when we have that extra water causing floods, it could be directed somewhere else so that we can solve drought conditions?
Yeah, absolutely.
But before you answer that, can I just ask a favor that you kind of repeat the question, at least paraphrase the question, because we are recording things. So.
Sure. As I understood the question, it was how do we manage the cycle between drought and flood and huge increase in water supply, and when you can't get rid of it fast enough, and then a crushing drought where there's no water at all. That is absolutely a huge issue for us. One of our agency's primary mandates is the statewide water plan that we create every 5 years to address just that. And that is a pretty substantial effort across the state, involving hundreds of people that are planning on a 50-year horizon on how much water do we have now, or are we going to have in the next drought, how much are we going to need, and if we're short, how do we come up with it? The project that you guys are working on that we funded is a off-channel reservoir, which is designed, I'm sure you can speak to that, to capture when you have high river flows that are going to wash out to the Gulf of Mexico. LCRA can pick up the gate and fill up a reservoir. There are other, it's not really IoT, but the other ways to address that are, just standard reservoirs. The reservoir is really a time machine that captures your water inventory in flush times and saves it for your drought times. Aquifer storage and recovery,
Which just got passed.
Is a big one where you can take water out of a reservoir or an off-channel reservoir and pump it into an aquifer underground, and it's essentially a banking mechanism. So there's not a lot of, or not that I'm aware of a very heavy tech element around that yet, but that's bridging the gap between the flood and the drought is kind of one of the things I think of as kind of the holy grail of water management, and I'm sure we'll get there.
That's exactly right. I think one quick thing I'd touch on to expand on that is, so that irrigation system I was mentioning is about 900 miles of canals for rice farming. Right now, sensors are too expensive to know whether there's water in it or not. And so when it's time to go send water, we have to send the maximum capacity that they have. If we can get low cost sensors that work on low power networks, that kind of stuff, there's some opportunities for us to manage the consumption side. So exactly like Peter was saying, that's the strategy, right? Keep it when you've got it, store it when you've got it, so you use it. But I think the technology can come into play in trying to use as little as you can to meet the need, the need that you're serving. And so, if we can apply technology to know a little bit, the higher resolution picture we have of where things are, the more effectively we can manage those systems.
Quick follow-up on that. One thing we've seen in the ag community is obviously getting more mileage out of the water they've got.
Yeah.
And it's been in bits and pieces, at least from what we've seen so far. It hasn't really been aggregated, and the partnership element hasn't come together. But we've seen a combination of spectral imaging from drones measuring the health of crops, which can be integrated with soil moisture probes in the ground and calibrated with we have NASA satellites measuring soil moisture, integrated with weather planning and precision irrigation, LEPA, low energy precision application irrigation systems. So to the higher resolution, if you can put that entire picture together in real time, a farmer can irrigate at a level of precision to the crops that need it in the area of production that the soil is driest, and you get a lot more mileage out of that same amount of water, and in the background be building a data collection that's integrated across all elements of the water weather picture for that crop in that area. And it feels like we're on the early edges of that, but that's hopefully something we'll move towards.
Okay, I unfortunately have to bring us to a close to try and keep us anywhere close to on time. So first of all, I'd like to thank our panelists for joining us today. So if you all give a round of applause.
Thank you, guys.
Thank you very much. I appreciate it. And we're going to switch over here real quick. So Rhonda and John, if you guys can move forward, we'll get started with the next one.